Right, so we're going to be using analytical geometry to prove shapes of parallelograms, rhombuses. We're going to be using the formula to help us in shapes. So these are all applications that we're looking at. So what I'd like you to do is to revise the properties of your quadrilaterals. And for my gentlemen, they're on page 168 in your textbook. They're from grade 7, sorry, grade 9, 7. They're from grade 9, and you just need to be able to recognize your quadrilaterals and be able to use those properties to help you. So we're using these properties in our analytical geometry. Okay, so when we were doing the midpoint formula, we saw how we could use the fact that the diagonals of a palm bisect to enable us to find where they intersect and to find the fourth vertex of a palm. Okay, so that was using our midpoint formula. We're going to use the gradient formula as well to do some things. And where can we use the gradient formula? Well, we can use it to show the parallel lines. Okay, so to show that lines are parallel, we would need to show that the gradients were equal. Okay, so to show parallel lines, we're going to show that they have equal gradients. Like the opposite sides of a palm, those would be parallel lines. We can use it to show perpendicular lines. So if we have a rhombus or a square, one of the properties are that the diagonals are perpendicular. So we would be able to say, well, the product of the two diagonals has to be equal to -1. We can use it to show that a triangle is right-angled. All right, so if you have a triangle and you could show me that the gradient of AB times the gradient of BC is equal to -1, then that means that AB and BC have to be perpendicular. That's what we learned about perpendicular lines, which means that angle B would have to be 90. And we can use it to prove that a quadrilateral is a palm, a rhombus, a rectangle, or a square. Okay, so these are just a photo of notes that I made about how do we prove that a quadrilateral is a parallelogram first. Okay, so the easiest way to prove that a shape is a parallelogram is to prove that the diagonals bisect. That is your easiest way to prove that something is a palm. Okay, so I've written there, just got a bit chopped off. This is the easiest way. So if I said you prove this shape as a parallelogram, your easiest way is to show me that the midpoint of one diagonal is equal to the midpoint of the other diagonal. You could also prove that the gradients of AD and BC were equal, or the gradients of the gradient of AB and DC is equal. So you'd have to prove that both pairs of opposite sides were parallel. Or you could prove that the length of AB was the same as the length of DC, and the length of AD is the same as the length of BC. In other words, opposite sides are equal. So any of those would make your shape a parallelogram, but the easiest one is the first one. Show me that the diagonals have the same midpoint. If you wanted to prove that something was a rectangle, you would first have to prove it was a parallelogram, okay, by choosing one of the above, but probably the fact that the diagonals bisect, and then prove that one interior angle is equal to 90 degrees. So if you can prove that an angle is 90, so a palm with one interior angle equal to 90 is a rectangle. And then with a rhombus, again, you'd first prove it was a parallelogram, and then you would go ahead and show me that when you took the two diagonals, AC and BD, you'd show me the product of the gradients is -1. In other words, the diagonals are perpendicular, so it must be a rhombus. Okay, so you need to go through these so that you know how to prove that a shape is a palm, a rectangle, a rhombus, a square, trapezium, or a kite. All right, so I've just got 3 examples to work through. The first one actually tells you that ABCD is a trapezium. So I know that in a trapezium, it's got one pair of opposite sides parallel, and they tell me that AB is parallel to DC. Okay, so I've marked those 2 lines parallel. All right, so we've been asked to first find the gradient of DC. Okay, gradient of DC is a wide D minus a wide C. Okay, so the wide D is -1 minus 0 over 0 minus 3, -1 over -3, which gives me +1 over 3. Okay, and then just check, yes, DC does have a positive gradient. It is going up from left to right, so that is a feasible answer. Okay, then number 2. Find the value of A. So A, little a, that's what they're looking for. That's what I'm looking for. Okay, so what happens with these kind of questions is it's a build on from the previous question generally. So what did I just prove? I just proved that the gradient of DC is equal to 1/3, and I know that AB is parallel to DC, so the gradient of AB is equal to the gradient of DC. So I'm going to be using this to help me with the next question. Okay, so here's A and B. So the gradient of AB is equal to the wide A minus the wide B over the x at A minus x at B. So it's going to be equal to 2 minus 4 over 4 minus A, which is going to be, sorry, 1 moment, let's try again. Okay, the wide A, so 2 minus 4 over A minus 4, which gives you -2 over A minus 4. And what is a gradient of DC? It's 1 over 3. So that means that I have an equation because these 2 lines are parallel. Okay, so we either cross multiply or we find a lowest common denominator. Whichever way you do it, you're going to end up with -6 is equal to A minus 4. And then we're going to add 4 to both sides to get the A alone. And we're going to end up with -2 is equal to A. And again, check. Can you see that your x-coordinate here would be a negative, so that is a feasible answer. All right, now what do we need to do? Well, we need to find the midpoint of AB. Okay, so the midpoint of AB using your midpoint formula, the x at M and the y at M. So we add the ends and divide by 2. So this is going to be A. Remember now, you're going to replace the -2 for your A, and your B is going to be 4 and 4. Okay, so we're going to have -2 plus 4. That's going to give me 2 over 2, which is 1. And this will be 2 plus 4 over 2, 6 over 2, which gives me 3. So the midpoint of AB is 1 and 3. And then finally, we're finding the gradient of MP if MP is perpendicular to AB. So I know that this is a 90-degree angle. So that tells me that the gradient of MP has to be equal to, well, what's the gradient of AB? It's 1/3, hey? So the gradient of AB is 1/3. So that tells me that the gradient of MP has to be -3/1, which is -3. Okay, because we're told that the lines are perpendicular to each other. Okay, number 2. Prove that ABCD is a parallelogram. Okay, so I said to you that to prove a palm, we could either prove that the opposite sides were both parallel using the gradients, the opposite sides were both equal using your distance formula, or the easiest is to work with your diagonals. So I'm going to join the diagonals, AC and BD. And I'm going to show that they have the same midpoint. Okay, so midpoint of AC is going to be the x at A plus the x at C over 2 and the y at A plus the y at C over 2. Okay, so that's going to be -1 plus 3 and 4 plus 0 over 2. So the midpoint of AC would be 1 and 2. Okay, what is the midpoint of BD? All right, so the midpoint of BD is the x at B plus the x at C divided by, at D divided by 2, and the y at B plus the y at D divided by 2. And that's going to be 5 plus -3 over 2 and then 6 plus 2 over 2. I've just realized that this should be a -2. It's in the wrong quadrant there. So there should be -3 and -2. Apologies. Okay, let me just quickly go back and change that. So this should be a plus -2 there. All right, so we've got the y at B, 6, plus the -2. Okay, so that's going to give me 2 over 2 and 4 over 2, which gives me 1 and 2. So now I can say, therefore, the midpoint of AC equals the midpoint of BD. Therefore, ABCD is a palm, and the reason would be diagonals of quad bisect. So because the diagonals bisect, this has to be a palm. All right, so that's proving that it's a parallelogram. Right, now what do we need to do? We need to prove that ABCD is a rhombus. Okay, now a rhombus is a parallelogram with diagonals that are perpendicular. So if I can prove that my two diagonals are perpendicular, then that palm that I've just proved must now be a rhombus. Okay, so what I need to do is I need to find my two gradients. What is a gradient of AC? Okay, so A, let's just write this down. A is -1, 4, and C is 3, 0. All right, so the gradient of AC is a y at A minus a y at C over the x at A minus the x at C. So that gives me 4 over -4, which is -1. Okay, and what is a gradient of BD? Okay, so B and D. B is 5, 6, and -3, -2. Okay, so gradient of BD, the y at B minus the y at D. And remember, we're subtracting a negative there, so I should have put that in a bracket, over the x at B minus the x at D. Okay, so that gives me 6 plus 2, which gives me 8, over 8, which is 1. Now, if we look at the gradient of AC times the gradient of BD, it's 1, -1, times +1, which gives me -1. So the product of the gradients is -1. Therefore, AC is perpendicular to BD. Therefore, the palm is a rhombus because diagonals are perpendicular. So that changes your parallelogram into a rhombus because it has diagonals that are at 90 degrees. Okay, finally, we're just looking at a triangle quickly. All right, so quick revise. Find the length of GF. All right, so remember your distance formula. Just a quick reminder. It's x at G minus x at F squared plus the y at G minus the y at F squared. All right, so what are these going to be equal to? All right, we can see G, here it is. So it's going to be 3 minus 6 squared. The y at G, -2 minus 2 squared. Okay, so GF squared that's going to be -3 squared plus -4 squared. And we can see now it's our 3, 4, 5 triangle, but we'll carry on. Square root of 25, which is 5 units. So GF is going to be 5 units. Okay, now they want the gradient of GF. Gradient. So it's a y at G minus a y at F over the x at G minus the x at F. Okay, the y at G is -2 minus 2. And then the x at G is -2, the x at G is 3 minus 6, so that's -4 over -3, which gives me 4 over 3. All right, prove that EFG is right-angled. Well, we can see that the right angle, if it's anywhere, is going to be at G. It looks like G is the right angle. Therefore, I need to show that EG's gradient times GF's gradient is equal to -1. Okay, I already have Fg gradient. So the gradient of Fg was 4/3. So the gradient of Eg is going to be equal to, and I'm just going to write E and G here so that I've got them on my page. E is going to be -5, 4, and 3, -2. -5, 4, and 3, -2. Okay, so the gradient of Eg is a y at E minus a y at G over the x at E minus x at G. So that's going to be 6/-8, which is negative. And then divide 2 into the top and the bottom. That's going to give me 3/4. So if I take the two gradients, so I've got 4/3 times -3/4. And can you guys see that's going to give me -1? That means that triangle EFG is right-angled at G. Alright, so I've just proved that the triangle is right-angled at G. I'll quickly just put, oops, sorry. Okay, so E -5, 4, 3, -2. And F 6 and 2. Okay, so I have just proved that that is 90 degrees. All right, now we're going to finish this by finding the area of this triangle. Okay, now if you remember, we worked out earlier that GF was 5 units. That was from our first question. We have worked out that angle G is 90. That was what we've just done. And do you remember that for a triangle, the area of a triangle is a half times your base times your height. So because I have asked you guys to prove that this angle is 90, we can use GF or EG, it doesn't matter, one as a base and the other one as the height because of that 90-degree angle there. Okay, so we're going to say that this is a half times GF times EG. Okay, now I know that GF is 5 units. I've already worked it out. But I need to know how long EG is. So you need to quickly go and you need to work out the length of EG because we don't know what that is. Okay, so the x at E minus x at G squared plus the y at E minus the y at G squared. Okay, so what I have, this is going to be -5 minus 3 squared. And then 4 minus 2 squared. So that's going to be -8 squared plus 6 squared. 4 plus 2. So that's going to be 64 plus 36. square root of 100, which gives me 10 units. So we need to calculate EG, and we've just worked out that it is 10 units. All right, so now we can do our calculation. Sorry, that's very messy. All right, so what is my sum? A half times 5 times 10. Well, a half of 10 is 5, and then 5 times 5 will give me 25 square units. So if you're going to be asked to find the area of a triangle using a half base times height, the question will draw your attention to a 90-degree angle to show you which is the base and which is the height.